In this module, we will continue the same topic as we discussed in our previous module, that the design of continuous sterilization, actually the indirect method. So in previous module, we talk about the spiral heat exchanger, but in this module, we will talk about the indirect plate heat exchangers that consist of altering the plates through which the countercurrent streams are circulated. So the plates are separated by the gaskets, and the failure of these gaskets can cause the cross-contamination between the two streams. Also, the clearance between the plates are such that the suspended solid in the medium may block the exchangers, and thus the system is only useful in sterilizing completely the soluble medium. If the medium is not soluble, then there is a problem. So, however, the plate exchanger is more adaptable than the spiral system. So in spiral system, then that is only the limitation that you can utilize that in a soluble medium. So the plate exchanger is more adaptable than the spiral system. So in spiral system, the extra plate may be added to increase its capacity. So the continuous steam injector injects the steam directly into the unsterile broth. So the advantages and the disadvantages of this system summarized by Banks in 1979. So as concerned, this method is very short. Almost this method can be utilized instantaneously. Heating up time is less. So it may be used for the medium containing suspended solids. As compared to the previous method, it involved the low capital cost. In this, that easy process of cleaning and maintenance, high steam utilization efficiency. But however, in this case, there are the disadvantages. The first one is the foaming may occur during the heating. So when there is a steam and you are directly blowing that medium with that steam, then there is excess of foaming. On the other hand, if we give the direct contact of the medium to the steam, then that will be the condensation. And then what happens? The allowance be made of the dilution of the medium. So requires for the clean steam. So if we have a direct, sometimes there is particulates or some heavy metals that can be present into that steam. So that should be free from the anti-corrosive additives. So in some cases, the injector system is combined with the flash cooling, where the sterilized medium is cooled by passing it through an expansion valve into the vacuum chamber. So cooling then occurs virtually instantly. So in this slide, you can see that this whole system of the continuous sterilization system during direct steam injection. So you can say that this is the cooling heat exchanger and the preheat exchangers. So cooling water out, unsterilized medium, then inject, and then this one is the steam directly enter into that, and then is the holding coil, and then is the expansion valve, and this is this expansion chamber. So steam to the vacuum, and then is back to the cooling. So this is the sterilized medium you can get, which is the sterilized medium. So this is the typical flow diagram of the continuous injector flash cooler sterilization. So in some cases, a combination of the direct and indirect heat exchangers may also be used. So this is especially true for the starch-containing broths when the steam injection is used for preheating steps. Because as concerned, the direct as well as the indirect both have some advantages and disadvantages. So sometimes when the medium is very viscous and there is a less flow, then there will be difficult to sterilize the medium. This whole story of medium sterilization, either in the batch or in the continuous sterilization. But when we focused about the solid state fermentation, then there is a limitation. So in solid state fermentation, then there is the only choice of the batch sterilization. But as concerned the continuous sterilization, that is mostly recommended for the submerged fermentation or the liquid fermentations.